JavaScript today, or whether or not we want to make today shorter. I don't know what everyone's opinions on it are, but a quick temperature check. If you want to haul through this and try to make as many inroads as possible on the regexes, we can do that. And if you want to retire earlier when we finish this and have some time to socialize, we can do that too. Does anyone have a preference for one or the other? If you want to keep moving on with the code, hand up.
I'm neutral.
So we got 4 or 5 that if you want to retire early and you want to have an easy day. Okay, so there's no one that has a preference for that. So we're gonna go through it then. And,
there's no such a thing.
There is no such. That's right. March on and see where people stand on it. Okay.
That graph you just had up, or the table, I was surprised to see that they consider Splunk a database. I mean, I realize number 13.
Number 13.
Yeah.
Splunk. Yeah. So I mean, like I can't speak for it. You know, I'm not even gonna try. I don't use SAP. I don't use Splunk. I don't use Solar. I use MariaDB quite frequently. I use Access quite frequently. I don't use Elasticsearch or Redis. I've done DB2 and I've done everything worth it. But my PostgreSQL is my go-to. That's my favorite piece of technology. Okay. So are we ready to? We're ready to go. Okay. So today what we're going to be covering is bugs and errors. In short, we have already assumed while we've been developing all of these things that all of the technology is going to go fine and dandy, that there's not going to be problems with it. That's a ridiculously faulty assumption. I like the quote that this thing opens up with, so I'm going to go ahead and read it. Debugging is twice as hard as writing the code in the first place. Therefore, if you write the code as cleverly as possible, you are, by definition, not smart enough to debug it. So that, if you think about that, a lot of that is true. You can look at code and it can be very clever, and you can say, look how few characters or few lines it took me to get that job done. But as you infuse more cleverness into that code, it's going to require even more cleverness than that to figure out what's wrong with it. So if you make that mistake, you'll be suffering from it later. Okay, there's this thing in JavaScript called strict mode to start this off with, right? For me, the difference between strict mode and sloppy mode is not important, right? And I'm going to tell you that now. I can tell you some of these differences, but one of the reasons why I think this would be a waste of time is because if you're using JavaScript, you should be using strict mode. And sloppy mode, you should just pretend like it doesn't exist. So all you have to do to use strict mode is say use strict at the top of your program, right? Just like this, use strict. You can put it inside a function if you want. But my suggestion is when you're writing code, simply put it at the very top of the file. Start all of your files off with use strict and double quotes. And what that's going to do is it's going to tell JavaScript to enable stricter semantics than it would otherwise use. So when it's parsing, if it sees something like counter variable doesn't exist and you're assigning to it, right, it'll actually error out and it'll say you haven't declared counter variables. Anyone in here ever use Python at all? Okay, so what does Python do in this same situation? Does anyone know? Python has an interesting behavior, right? Where with Python, if you access a variable, right, you go to retrieve a value from that variable, Python will read that variable even if it's global. That's fine because JavaScript does that too. But if you assign to the variable, Python makes that variable local. So Python doesn't actually determine the difference between defining a variable and initializing it, right, with syntax. There is no let keyword in Python. There's a let keyword in Perl. Perl users, what's let? Mine, right? So Perl does this, Python does this, Perl does this, C does this, JavaScript does this, Python doesn't. This is the right way, in my opinion, to write code. It eliminates a lot of bugs. In JavaScript, you get it by using useStrict. For Python users, I'm sorry, that hasn't come to your language yet. Hopefully someday. We're going to skip everything else on that because, quite frankly, I think a lot of that is simply telling you what JavaScript used to be like, and no one uses JavaScript in sloppy mode, or should. And I think we're wasting a lot of time by doing that. So when it comes down to errors, one of the big questions is like, what is an error and when do you use it, right? So an error, in computer programming parlance is something you throw, right? And when you call a function, you expect it to return a value. So because you throw an error, it's a function essentially saying something went wrong, boom, explode. It's different from when you return a value otherwise. And a lot of people will question when you're supposed to do one or the other, and there really is no golden rule for it. Generally speaking, I guess if you're going to generalize and you're going to push about this, if there's something that you expect no one to ever do, that everyone would agree implies something went wrong, throw an error. Dividing by 0 is the case, so we probably find most programmers agree you should throw an error, right? If, however, you're asking a question, even if that question doesn't necessarily make sense, my suggestion would be don't throw an error, right? So
say that again. Say that last.
If you're asking a question, right, or you have something like a method, and there is a way for that method to not throw an error, right, my suggestion is don't throw it. Let me give you a case in point. If you're asking someone what their favorite color is, right, you're asking an object what its favorite color is or something of that sort, you know, query for favorite color, and one of those objects represents a blind person, you might want to return not applicable. Because it's a very common thing, right? For some people, they may just simply say, I don't have no preference or not applicable. Those are all valid, in my opinion, return values, or could be valid return values. You can make them valid. It's not the same thing as like a divide by 0 error. My point here is that this is part of programming design. And the reason why it's a bigger issue is because when you throw an error, you get a different return path from your code. So if you have code that, for instance, communicates with a database, it may do something like when that code is done, clean itself. For instance, get me the account balance from my bank statement, right? And then after you get me that, disconnect from the bank account from that database. There's a certain process that disconnection has, where it may clean up some things in the background, right? But if you get me my account balance and I simply don't have an account, and you throw an error because of that, you could miss that second part. You could miss that cleanup, right? So there's two different code paths at that point. We're going to see some of that here, but that's why people, you know, there's this debate about when do you throw an error and when do you return, you know, no account found or something like that sort. So what we're seeing here is they're actually giving, I believe, yes. You could add a comment. So they're showing you here, you know, this is part of the documentation that they're showing you can create on functions. There's something out there called Typescript, and if we don't get into that in a later class in this material, we can certainly do something on it. I've presented Typescript in HL before, but you can comment out on your functions, and you can show essentially here what it's taking, right? So this takes something like village state and an array, village state and an array, the array is the memory, and it's returning this here, which is an object that has a direction and a memory address, right? This is a type comment that he's got right here for that function. You can do this. This is not a very good idea in my opinion, because there are now better ideas. But today you would use something called Typescript, and it would actually take this comment, what this comment is representing, and it would pull it right into the declaration. So you would put all of these types of things in the declaration. You would say state is a value state. You would say memory colon array, and then you would actually say that it returns an object with these types of things in it. So TypeScript gives you the ability to not make this a type comment, but actually put that information directly into the declaration of the function, right? So he's just showing you this is what a comment could look like that would help you understand and reason about that function. Does anyone remember in the last class we actually went through one of these? I think we went through one and I said, what does this take and what does this return? And we went through and we saw the property names, and I said, okay, if it has property names, it's taking an object, and what is it returning? It's returning these two from things. This has got to be an array. And we showed it. That wouldn't have been necessary if we had a comment like this, and that's what he's trying to show. He's trying to show if we comment things like this, comment them like this, then people don't have to try to figure it out, right? They can see right there. It's taking a village state object, it's taking an array, it's returning an object. Okay, testing. Testing is not difficult, and when you write computer programs, you don't just test errors, right? You test everything. You test returns you expect to get, right? You'll test things you expect not to get. You'll test things that you expect to throw errors, and you'll test things you expect not to throw errors. And how many of these tests you write, the more the merrier is the general rule of thumb. But you usually leave that over to someone in QA that actually has the role of writing tests. Programmers also write tests frequently, and there's test-driven development where a programmer will write the test before he writes the code. And then he'll write the test. He'll say, okay, it's failing now. Now I have to write the code to make it pass. And they call that test-driven development. Here you're seeing an example of some of these tests. So we create a function test, and it takes a label and a body, right? And we say, if the body doesn't return true, then we want to log to the console, failed, with the label, right? So we're testing here. We're giving it a label, right, which is this, convert Latin text to uppercase. And then we're giving it a body. And this is what the body is going to be right here. Now, if this returns false, the test has failed, and you're going to print this top thing, convert text to uppercase. If the body is true, then the test passes, and you don't print that, right? So that's really all there is to it. And when you look at a testing framework, there's one called I think it's called should.js, and that's kind of like the go-to. It does things slightly differently. So you would actually say like string dot should, dot b dot uppercase or something goofy like that. You'll see the syntax there. It's a lot more cute than this. But he makes a comment, I think, in this text where he actually says here, writing tests like this tend to produce rather repetitive, awkward code. In my opinion, it's not repetitive and awkward, and the author's opinion is repetitive and awkward. The author doesn't go into this, but there are multiple different ways to write tests in JavaScript that are less repetitive and less awkward. So let's take a look at it and debugging. Let's see here if we can pull up should.js. Yeah, so this is an example of like a should.js test. You'll see this too for people that use this library. This.object.should have property ID, which is a number. That's another way to write a JavaScript test using should.js. So if the method here is considered awkward and redundant, some people prefer this should.js thing. And there's a lot of these testing frameworks out there that may help you. So debugging. This is kind of cool. We're going to go through this, and again, there's lots of different ways to run JavaScript. One of the methods to run JavaScript is inside of Chrome. Other methods of running JavaScript is inside of Firefox or inside of Node. I'm going to show you how to use the Chrome Debugger, right? So if you work inside of Node, there's a method in which you can debug that too, but I think it'd be less practical for me to show you that. So using Node, what we're going to do is I'm going to copy this function here, right? Now, does anyone remember how do you get the JavaScript debugger open in Chrome? Control-Shift-J. Precisely. That's exactly right. Control-Shift-J. It's going to pop me open with this window. You should all see something like this. Yeah, there is a method where I think you can, like, that's another point too. You can click this thing here, and then you can go down to like something cool, and it's somewhere in there. Yeah, okay. So we go down here to Node, and then I'm going to go to, actually no, I'm going to go use this thing. And I'm going to paste the test right here, right?
Option Command I on the Mac.
Option Command I?
Yeah. Okay? So now what it's actually done is it has put this function into memory, right? So now that that function exists in memory, you can actually see it. And if I go number to string, like that, it'll output that function. So I've given it the function into the debugger. It has put that function into memory, so popped it into memory, and I've verified that that function is in memory right here. Now what I should be able to do is right-click and hit Show Function Definition. And you see it pop up right here at the top. Now you can set breakpoints by clicking on this, right? So if I click on one of these numbers, these line numbers on the left,
Evan, can you go before you said something about breakpoints? What was before that?
I click on I type in the function's name,
Yep.
and then I right click and I hit show function definition.
Okay.
Right? And now what it's doing is it's showing me the in-memory copy of that function. Right? And the reason why that's necessary is because it's no longer just something I'm typing into the console, it's showing me as it exists in memory. And after you see it as it exists in memory, you can have what they call breakpoints into it. And I don't think any of this is in the actual lesson, but because it's so short, we can play around with different things. Yeah, see, so this is all the lesson says. We can decode the behavior to use the debugger capabilities of the browser. Browsers come with the ability to set a breakpoint on a specific line. I don't think they actually show it to you how it's done. So I'm actually showing you and explaining to you this paragraph right here. So if everyone's following along, did everyone do this? Is everyone with me on this? Or Control-Shift-J opens up the debugger. We're pasting the function into the code. We type the function's name, and then it's going to give us this little representation at the bottom. And then we can right-click and say show function definition. And that opens it up right here. Are we there?
No, but I'm doing it on the Mac. It's Command-Shift-I to get into the bugger on the Mac.
Option Command I.
Option Command I.
That open, but when I right click on it, it doesn't have an option for show.
I'm there now.
Yeah, I didn't find that one.
Okay. You're there. You're not there, Marco?
Right.
What if it's not showing you the option for function definition?
Right. I can,
Let me take a look.
I can input the function in there.
Let me ask this question. You are using stuff.
You're here.
Yes.
Just one time. You followed him, huh?
Oh. No, that's
Right click on the copy of the function in memory. In order to get it to show you the function in memory, you have to type the function's name. Coming back up here, I'm going to show you. This is the function I typed. Notice there's no right click on it. I typed in number2 string right here. I typed that in. Or you can just say number tab, right? Because mash on tab, that golden rule we have, applies here too. You can right click on this and go to this one, right? Show function definition. Now it's available for you. Okay, doing that, it comes up at the top, right? You'll see this here, VM54. That is the Chrome virtual machine, right? So V8 has its own little virtual machine that executes JavaScript code and does all this very geeky stuff, which we're not going to get into. But that's actually telling you that that's where that's at in memory. Okay. So now we have the ability to set breakpoints. And in most debuggers, I think this is maybe a Borland convention, but you see it everywhere. If you click on the line number, you're going to see a blob appear. Something like an arrow or a color or something like that. And that's going to say essentially the breakpoint is set. Now what I want you to do is I want you to watch right here. See where it says breakpoints? This is empty. When I set one, something's going to happen there. I don't remember what, but let's give it a shot. So I'm going to come right down here and we're going to say breakpoint on 8. Boom. There we go. It's showing me the breakpoint is right there. The check mark near the breakpoint logically means the breakpoint is enabled. Right? When a breakpoint is enabled, it means when that code is executing, that line of code, it's going to halt execution. It's going to give you the ability to see what all of the variables are during that phase of the execution. JavaScript has a very high-level debugger. It's going to print out every variable that you have and show you what all those names are. And some debuggers, if you've used lower-level languages, you don't have that kind of joy. You just essentially see a big blob of memory. This is a lot nicer. So, what we're going to do is we're going to look at this code that they've given us, which we know is bugged. And I'm going to show you how that looks in the debugger. Console log number to string 1310. I'm going to print this right here. Console log number to string 1310. And boom. You see how it says paused on breakpoint? Are we seeing that? Paused on breakpoint means that the execution was halted. And now it's giving us a chance to introspect and see all of those variables and what they're set to, right? So let's take a look at it. You can see here the local base is 10 and n is 13. We called it with 13 and 10, right? The next time I iterate through this, I would expect it to not be equal to that. In order to jump through and do it one more time, let that loop run once more, all I'm going to do is hit resume script execution. Resume script execution is going to continue it again until the breakpoint hits again, right? Boom. Now what do I get? Base is 10, n is 1.3. Do it again, what do I get? Base is 10, n is 0.13. Okay, so what we've done in this exercise, for those that haven't read the book at all, trying to find the thing, everyone, we have a function here called number2string. It takes an n and it defaults the base to 10. Essentially what it's going to do is you give it an integer and it is going to create a string that represents that integer. So if you give it 123, right, it's going to take that 123 you give it and it's going to print it out on the screen. In some languages, it's more important than in JavaScript because JavaScript will stringify numbers for you. So you don't ever have to do this. But in a language like C, right, 123 is stored as 1 byte, 8 bits in memory. And if you want to put that out to the console, you have to write something like this. We're not going to go over that today, but I am going to show you how this works. If we take n, 123, and we say modulus 10, what are we going to get? 123 divided by 10 is 12, remainder 3. Modulus returns the remainder. You're going to get 3, right? You're going to get 3 plus an empty string, because result is an empty string. And we're going to set result equal to that. So we gave it 123, and now we have 3. The second time around, right, 123 modulus 3, right? But it's no longer 123 because we set n divide equal base, right? So what you want to happen here is you want every time for that 123 to become 12, and then that 12 to become 1. And each time you're going to essentially say modulus 10 to get the remainder after you divide it by 10. Then you're going to divide n by 10, and you're going to slowly crawl through that number until you get all of those digits in a character string. Does it just click for you? So 123 modulus 10 is 3. Then we take 123 and we say divide equal 10. It's the same thing as saying 123 divided by 10 is 12. We set n equals to 12. Then we do it again. Now we're going to say 12 modulus 10. That equals 2. And we're going to say 12 divided by 10 equals, well, divided by 10, 1. 10 goes into 12 once. Then we're going to say, we're going to loop back around. Now we're going to say 1 modulus 10. Well, 10 goes into 1 goes into 10 0 times. The remainder is 1, right? Yeah. So now we've went through the first time we got a remainder of 3, the second time we got a remainder of 2, the third time we got a remainder of 1, and each time we take it and we add it to the result. 3, 2, 1. 123 is the input, and we've created the string 123. Okay, so when all of this is done, we want that out. Now here's the problem. It's not working. This is his situation. He's giving you this function string, and it doesn't work. And the reason why it doesn't work is here. We're saying n divided by equals to base, right? So I told you earlier, 123 modulus 10 equals 3. Who said 3? You again? Okay, yeah. He's always right. He says something, chances are he's always right. 123, right, divided by 10 is 12, remainder 3. The modulus is the remainder. 3 is your answer. Now what you want to do is you want to say 123 divided by 10. What does that equal to? 123 divided by 10. Not modulus 10. 12.3. Now we have a disagreement.
There you go.
So this code here is written under the assumption that the answer will be 12. But JavaScript converts it to floats. And the answer is 12.3. And that's the bug. The bug is that when we set n equal to the result of n divided by 10, we're getting fractions. Now, rather than having 12, we have 12.3. And as we keep going through this, we keep getting that result more ridiculous, n 0.13. If I run through it again, I'm going to get, 0.013, right? And then if I run through it again, I'm going to get, and this is, now you're seeing a floating point error here, but I'm going to get another 0.1, right? So what I'm going to do is I'm going to restart this. Now that we understand how the program works, we understand what the goal is, and we're going to take one more look at it. And then we're going to hopefully understand this bug. So I'm going to deactivate the breakpoint because I don't know the way to get out of it. Otherwise, we're going to hit go. Now I'm going to do it again. Boom. Okay, the first time around, base is 10, n is 13.
Yeah.
We're providing it 13 and 10. Second time around, base is 10, n is 1.3. Third time around, base is 10, n is 0.13. See what's happening? We want that assumption to be at this point 1, and we're getting 0.13. Right? So here's what the call stack is supposed to look like. It actually looks like this. It's supposed to look like, you didn't even show what it's supposed to look like. Oh,
All the numbers, basically.
It's supposed to look like the numbers, right? It's supposed to be, 13, then it's supposed to say 3, and it's supposed to say 1, and then you're done. Right? Okay. So if we go back and we do our example, let's do that, and I'll show you, because our example was 123. Console log 123.10. I put back the breakpoint, and then I hit enter, right? Now it's showing you up here at the top, you'll see it, because it actually shows you the arguments that were passed, and 123.10, right? Base 10 and 123. First time around, base 10 and 12.3. Second time around, base 10 and 1.23. And then it just gets more crazy as that n gets longer and longer, because it's not doing integer stuff. So fixing it, which is the very last thing we're going to do before we go on lunch, or dinner, whatever the hell this is. Fixing it, it tells you right down here, you want math.floor and divided by
Yeah.
Alright? So we have some people are definitely clicking off with it. So how do we do that? We come back up to where we declared the function, right? There's our big ugly function there. And all that I'm going to do is say n equals n divided by base. And I'm going to say math.floor. Enter. Now I do the same thing, number 2 string. And I'm seeing the function. I can right click and say show function definition. And it comes up here. And now what I'm going to do is I'm going to put the breakpoint again here. You'll notice this time we have math.floor. See that? That's the new thing. We didn't have that before. I'm going to go to console.log, number 2 string, hit enter. And then I'm going to show you right here, base 10 and 123, first iteration. Base 10 and 12, second iteration. Base 10 and 1, third iteration, and now what's going to happen? Now the next iteration, n is less than 0, and we're done. And what's the result? Well, the result there, because he's apparently fudged his return, is nothing. But let's see here, if I... Yes, there we go. Okay. Number 2 string, 123.10. It should be returning that. That's what we want it to return.
What do you do wrong with the result?
That's a good question. So it is showing. We got to go bigger than
Bigger than what?
the scenario. They have different. They have 6, 7, 6, 11. They have 16 people in their channel.
Yeah, I went just today to get the, because there's a different process, and then they have to give you a voucher, and then you have to wait till they approve it and things like that. So I went back again today and said it's going to take a week. It was already approved for the grant, but it's going to take a week now to release the voucher from their
When's the class start?
I'm going to start on September the 4th, but they have a tour at school this Thursday.
There's a bunch of different lines.
in the morning. 9.
Which is one that I like, but there's a lot of different MIRC is another really popular one.
Yeah, like when I was using it, it was like in 1999.
Yeah. MIRC is the other guy one. It's got the little GUI and everything.
All right. We ready to get back to it, team?
Yeah. Do it.
Okay. Let's finish this up because we're over halfway done with it.
Wow.
So yeah, that's what I said. Today's gonna go by quick.
You're fast. Fast and furious.
All right. So now we're looking at this function he's created called prompt number. If we look at this function, prompt number, we'll see that he is returning null if it is not a number. We went through this earlier. I went through things that I was going to show you, but not necessarily spend a lot of time on because they're really not that important. In JavaScript, there's something called nan, not a number. It's actually part of floating point, the floating point standard. It's just simply not something you will interact with much, right? So I introduced this as a concept. There's a number, not a number, and here's how you use it, right? We didn't spend much time on it because there's not really a need to. So he can say prompt number, and then essentially what he's doing is you give it a question, right? It gives that question to a function called prompt, right? Prompt actually pops up a browser window and it says, hello, la 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 la, and then it gives you a box. Whatever you type in that box and slam on enter with is what the function returns, okay? So if I say prompt, what is your name, and you type in Bob, enter, then the return value of that call to prompt is Bob, right? So number, prompt, question, you're feeding it a question. It's expecting that question to be a number, to return a number. So if you ask it something, and your user types in 52, it's going to make that string 52 the number 52. That's what this is doing here with number. You have a notion of a string 52, and you have a number 52, right? Most of the time, JavaScript will do the right thing with whatever you give it. But if you want to be sure that what it is you're working with is a number, you can call number on the string, and you get a number from it. So we're prompting the user for something. We're expecting that something to be a number, right? And then we're setting that number to result. We're saying if that result is not a number, right, then we're going to return null. Otherwise, we're going to return the result. So if I say, what is your age? And you're an idiot and you tell me orange, right, there's no way for me to make sense out of that in a program that wants a number for your age. JavaScript is similar. So JavaScript will return not a number if you give me orange for the value of a number. So what it's telling you here is, one option is to make it return a special value. This gets back to that discourse we had earlier, where I said there is no golden rule about when you should throw an error and when you should simply return a value that represents the error. This is the method of returning a value that represents an error. If you call prompt number and you get back a null value, you know your user did not return a number. That is perfectly fine. There's nothing wrong with this method. The next method we show you, where we throw an error, is not any better. It's also not any worse. These are just different methods of doing the same thing, right? So, scrolling down. Okay, great. Okay, he's off on La La Land. He's not actually going to show it to you right away. He's showing you another example, right, where they do the same thing. Again, stylistically, I would have preferred him to go right into how we throw an error. But we're going to show you one more example where we're not throwing an error. You have this element called, this function called last element, and you give it an array, right? If the array has no length to it, it's an empty array, right? It's going to return an object with failed true. That tells me something went wrong. If you want the last element of an empty array, what am I going to do? You know, I'm going to return an object that says failed true. Otherwise, I'm going to return an object with the key of an element and a value of the last element. That's what the return value should be in last element. So this is another method of doing it. You have one thing that returns failed true, the other thing that returns the element that you're looking for. The point here is that nothing here is using errors, even though we're representing things that we would say in English are errors. Okay? Now here we enter the wonderful world of exceptions, right? So we have this thing called prompt direction. Same shit, different name. We give it a question. We prompt for that question, and that's a result. Now what we're going to do is say, if the result to lowercase, that result, if I give it an all capital left, right? It's going to lowercase it and compare it with the lowercase left. You following? If it equals the lowercase left, then what we're going to do is return L. If it equals lowercase right, we're going to return right. Essentially, this is case insensitive comparison. That's what he's doing. If you type your name in JavaScript, where you say like my name's Evan, capital E, lowercase v, capital A, lowercase n, something goofy like that, that is not equal to all lowercase Evan. The way JavaScript compares strings, it's case sensitive. This method says lowercase to the left-hand side. We're typing the right-hand side of it, so we're just going to type that lowercase, and now we're doing a case insensitive comparison. So we say we're testing for left, we're testing for right. Either one of these two are sane. Otherwise, we're throwing a new error, and this is the crux of this whole lesson. This is where the real meat of it comes in. Throw new error, invalid direction, and then throw it back whatever you get, result. Right?
It shouldn't say, the second line, it should say let result equals prompt direct question.
Let result, so this line right here?
Yeah.
Yes, where's the question there?
Shouldn't it say prompt direct question instead of prompt question?
No, because prompt direction up at the top is what you're calling to get a direction. Prompt is a core function in JavaScript that says, put up a dialog box, ask the user this question, and get an answer.
Now, I'm sorry. Okay, now I get it. I just click wrapper.
Yeah.
Okay, gotcha. Right.
That's exactly right. We would call this a wrapper function. That's precisely right.
Yeah.
Right? We're wrapping the function prompt, and we're specifically looking for two inputs. Right? All right. So, introduction to error. Throw new error. What does that tell you? Right there. If we have new, what is error? Anyone have the magical word for what error is?
A result.
In the back, Marco.
Object.
Object. Right? You can't call new and get back anything but an object. New returns the object. If I say new error, then I'm getting an object back. So throw in JavaScript represents an object, right? In this context. So we are throwing an object, an error object, right? Okay. Oh, good. We're good. So we have this function here, look, and it essentially says if prompt direction which way equals L.
Hey,
Yes.
did you explain throw already?
Yes. Okay. So the thing is like, how do I explain throw? You have this thing called error, right? And you've created it. Throw means use the error, right? So you have this thing called return, which sends you down one path, right? I call a function, the function returns back to me, right? So you use return to say, I'm done with this function, return back to whomever called me. Throw is the analog of that for errors. Throw sends you down the other execution path, but it provides you with this error object, right? So you can think of throw like return, and you can think of new error like the thing you're returning. But here's the thing about throwing an error. When you throw an error, you don't go back to the function that called you. You go back to the next function that has the wrapper around you, right? So we're going to see that in a little bit, how we catch these, which will make sense to you. But whereas when you return, you always return to the guy that called you. When you throw, you may not go back to him. You may go back to the person that called him, or the person that called that, you know? Whomever encapsulates at the lowest level, you know, or the closest to you encapsulates that error, right? You want to be the closest thing to you that encapsulates that error. You keep going further back, and you can have one ability to catch all of the errors in your program. One catch block for all of the errors in your program. And if you don't catch the error anywhere, what ends up happening is your program simply terminates. Nothing else happens. right? So if the error keeps going up, we call it bubbling up, right? If the error keeps bubbling up and nothing catches it, eventually it gets down to the area where nothing else can catch it, and your program just crashes, it terminates. Okay, so throw is going to be a little hard to make sense out of, but think of it like return with a little bit more jazz.
Yeah, or is that like printing? That's how I've never completely understood it, but I think I've seen it before where I know that when you're throwing something, it's an error that you're throwing, and it's going to go up to wherever the mechanism that you put in place to handle the error, which includes printing. So I kind of treat it. I always think of it like it's printing that error somewhere. As long as there's some code, it's throwing it to the place where the code can interpret it and do something with it. Then it comes back to the next line. So it's kind of, to me, I've kind of thought of it as like kind of a print statement, but a fancy one.
I always viewed it as